Hello, welcome back to Vertices LiveNoding. In this episode, I'm gonna talk about something like kind of basics, but basically it's all about mesh data, talking about vertices or verts, edges indices or faces indices. Also, basically, I'm going through these tutorials by Ian Scott 888, and this one in particular, he talks about how to create kind of new mesh object kind of operators in Blender. Uh, the script is not actually that complex. This is actually pretty basics, but I know that like if you try to make this, you can follow Ian's tutorial, and this will take you through how to do it using Python. But if I look at this, I know back then a few years ago I will be like really scared to look at this, but then which one is actually scary? Is it the Python script or the actual dealing with mesh data itself? Which one scared me? Actually, there's a lot of factors, but what makes it easier for me is that an add-on called Sverchok, and Sverchok really helped me with this. So yeah, so you can have a look at this data. You see a lot of like vectors, and then there's tree values and etc. Like right now at this point in time, I'm actually not this thing kind of familiar to me, and it's kind of easy to understand what's going on. And all we need to care is that how to put the mesh data together and then how to make it into 3D objects in Blender. So this is kind of makes sense for me now, but I want to show you how to do it using Sverchok, just this data parts. Okay, so let's get started. Uh, Normally, if you actually want to build something in Blender totally from scratch, let's say here you have like, okay, you can create 3D cube just by using that operator, right? Add cube. But let's say you are like in edit mode, and then you delete everything, and then I will just merge it into a single vertices. So a single vertices is just a point. The cool thing about Blender is that how we can treat a point, and then we can kind of shift D and duplicate the points a couple of times. So we have like 4 points there, if you can see it, and then kind of make another 4 points down there, and then you can kind of start selecting the points, and then Control F. Oh, actually not Control F. F. So F will generate a face, and depending on how you select the points, you will get the face that's kind of pointing with the normal pointing up there or down there. And then you can continue doing this until you get like a full cube. So we're gonna try to do this using Sverchok Add-On, and this is actually not that complicated at all. Actually, Sverchok make it really easy for us to do it. So let's get started. Sverchok Add-On, and I will start with something here. With Ian tutorial, he start with a bunch of vectors. Vectors is a tree floating value x, y, z, and this is to represent 3D mesh points. So we're gonna do that. Create. I'll just press Shift A and then search for vector in. So I have a node that does that. You can actually let me save this first. SV cube from scratch. You can actually create a vector from floating value like this. So float, so 3 floating value, it can be negative, can be anything, and you can actually join it using list join the data, and you're gonna end up with a vector, which is this guy. So we simplify the process and just have a vector. And let's see what Ian does. So he has a bunch of numbers. So -1. So these numbers, even if just you just look at the numbers and then you might get scared. But let's say if we want to actually visualize it, visualize the points, these numbers in 3D, I will be using viewer draw. So this is a single point, right? Plug the vector into the vertices, and you can see a dot there. It's really small, and especially on the MacBook Retina display, whatever, this is really small. So I need to increase the vertex size to maximum 10 here. So we can see a point at 0, 0, 0. So that's cool. In order to make what Ian is doing here, so the bunch of numbers is actually makes sense now, right? We can reposition the points in X and in Y and in the Z. Actually, we are not dealing with Z yet. Look at here with Ian, he actually have 0.3. Don't worry about the Z for now. We just have a point on the grid, on the floor, right? So that's a single point. We can have multiple points, so I will create list join and create the second points, plug it here. So I'm gonna move it. I just changed the X into like minus number. The number can be simplified. It doesn't matter as long as you can see the points. So that's the second point, and then make the third point. Here we're gonna make minus in Y, make another point. So we're gonna end up with 4 points. Okay, something like that. At this point, we can actually just bake it. So we have a single object, right? Oh, actually, we have 4 objects. Now that's something to keep in mind. You can see here the data says 4. So we can make this data into a single object. Just increase the join level list to 2. Now if we bake, we have 4 points but a single object. And if you go to edit mode, select all, F, you get a face. Now we want to create a face. In order to create a face in Sverchok, you can see here with a viewer draw, you either provide the edge indices or polygon face indices. So either one of that. What's the data looks like? If you just use a box and then use the stethoscope and look at the data. So the first one is the points, right? With the box, we will have 4 points. 1, 2, 3, 4, 5, 6. So a box with a 1 unit will have a points that looks like this. So we need the minimum of 8 points to create a box. Currently we have 4 points, 4 vectors to represent just the bottom part of the box, for example. But we need the edge indices in order to create a box which is just made of outline, or the actual face data. Face data looks like this. What is this? They are actually just like indices, index value that you can use to create a face. So if you have like 4 points like this, in order to create a face, you just need to connect them together. Okay, so that's pretty clear. So with these 4 points, I can actually just make a duplicate and then bring them up. So I make another 4 points and just put it to the side. And this is gonna be 1, 2, 3, 4. And I'm gonna kind of push it up in the Z so you can see. So the Z, let's make it like 3. And I will copy Command C and then paste it here for the new 4 points. So we have now 8 points. And how can we tell the indices? Here, Ian have the face indices with all these numbers, and if I'm not wrong, in his video he has this nice visualization showing the indices of box. Right? This is something that we can see here in using Sverchok Add-On. Just use index, viewer index. plug in the vertices into this guy and then turn on background so you can see clearly. Yeah, on my Mac, or on a Mac, it's especially crazy because it's really small. If I actually use Control and then scroll, now we can see the indices 0, 1, 2, 3, 4, 5, 6, 7. So I'm gonna zoom out again. It's crazy. Retina display is so small. It makes everything 4 times smaller. Anyhow, you can see the indices 0, 1, 2, 3, 4, 5, 6, whatever. Let's try to create a polygon face indices. We can do that using list input, I believe. So list input. So if we provide 4 numbers, this can create a face for us. So let's see the first one, 0. Let's try 0, 1, 2, 3. 0, 1, 2, 3. This is an integer for the index. If I just plug this into the edge polygon, we have a face. So it's really that simple. 4 integer or round numbers to represent the index that we want to connect together to create a face. So the order of these indices is important. It will create a face that's kind of pointing up or pointing down. So that's the normal of the polygon. If I bake it out, we have a face, of course. And this face, can you see which way is pointing? If we actually turn on the back face culling, where is it? Oh, this one, back face culling. We can see the one with the normal pointing the opposite direction. We know that the normal is pointing up here. It's not pointing down. We need it to point down because this is a box. So we need to reverse this. 3, 2, 1, 0. Now if we bake it, oh, it's baking it into. Is it updating? Let me try. Bake. Okay, we have the objects. Oh, we can't see it, that's why. We can't see it. It's actually creating a face there. We can't see it from the top because the normal is pointing down. So that's correct. Okay, let's continue. So apparently if we are doing it with that direction, so 3, 2, 1, 0. 3, 2, 1, 0. The normal is pointing down. Wow, this is a bit tricky to understand, right? I think you need to use your kind of thumb. So this is clockwise and it's pointing down. Okay, so yeah, let's try to make the top of this cube anyway. So we need the second indices. So list join. We're gonna create the second one here. We have 2 data. We want it to be a single data. So join list 1. The second one should be 4, 5. Actually, 4, 5, 6, 7. 4, 5, 6, 7. 4, 5, 6, 7 give us this result, which is kind of weird. Why is that? So apparently, well, it's a little bit weird, but okay, 4, 5, 6, 7 should give us correct result, but let's join 2. If I bake it out, we get that result, which is quite strange. I was expecting it to create just a face. Maybe I need to do it differently. 4, 5, 6, 7. Maybe I need to do the opposite. 7, 6, 5, 4. No, I believe 4, 5, 6, 7 was correct. That's weird. Let me check my other setup. So here I'm doing the same thing. I'm using viewer B mesh and join level 2 with a wrap. Okay. Go back to this guy, file, save as. So this is kind of interesting. So the data here maybe is not exactly correct. So we gotta check it. Let's get our box again and then use the stethoscope and look at our data. This is the correct data. It should look something like this. So with this data, let's check it out. So we probably need to list join once again, or just wrap it. We need to just wrap it. So the data needs to be wrapped. It was like this, you know. We apparently need to just wrap it again, so it's looking something like that. That's the data that Sverchok wants. So we need to provide it. Cool. Now this is correct. If I bake it out, it should be correct. And with this guy, if I turn on the wire, we can see we created 2 face and we have 8 points, and we kind of create 2 polygon face, and then it's almost like a cube, but not yet. Like here with Ian, you can see here, to create a whole box fully enclosed, we need to have 6 polygon face represented by these indices. Let's continue connecting the dots. So let me guess. The next one, 1, 2, 6, 5. 1, 2, 6, 5. I'm not guessing, actually. I'm really using my right hands, and then if I draw my right hand using grease pencil here, yep, this is my hand, and this is my thumb. This is my right hand, and these rotations. So this should be the normal pointing out, because I'm connecting the dots 1, 2, 6, 5 to create the polygon face that way. So let's continue. 0, 1, 5, 4. 0, 1, 5, 4. See, it's kind of working. It is working. Cool. So, oops, I deleted the indices. Let's continue. We only need 2 more face. It's actually, to understand this, it's quite fun, and I found it quite cool the first time I did it. Still kind of cool that we can do this. It's a little bit like a spider building a web. 2376. 2376. So Sverchok, the name Sverchok in Russian or Ukraine means what is Sverchok? Cricket? Okay, cricket was named cricket because there's another add-on for Rhino called grasshopper. That's why it's called cricket. But I think Sverchok is really more like a spider. The add-on can be called spider. Whatever insect. Insect is always like, they are probably like the best architects out there. So spider, I call this add-on spider sometimes. So anyhow, we have box from scratch, right? We are doing this components by components, and let me kind of select this. Oh, this is a trick. If you are using Node and you want to select just the ones connecting to the nodes, you can tap L, and then you can move it up. So that represents the vertices, and this guy represents the face indices, and each one has 4 values, 4 integer values to connect the dots to create a polygon face. You can also try doing it for indices, edge indices, and then doing it this way to create a box. At any time in point, if we ever want to, okay, make it a bit taller or something, you can do this one by one, right? Or you can use a float, just a number to represent the z value. That should be the same if you want a flat box. And now we can push the box like that. So we have a lot of flexibility here. Same thing, like with all this number, we can really create our own box. Sverchok, of course, have its own box, and this box we can have different divisions. We have size, but we don't have control over the size x, y, z. But here we kind of does. We kind of have a way to control how tall, or if you want to make it what's the width and the height and the depth, right? You can do it yourself. Let's see here. So for the bottom part, we can represent it with a number and just plug it to the z. Now it's kind of nice. We can control the bottom part. We can control the top part. You can also control the side and whatever. You can create your own box. Box is of course really simple. 6 polygon face, 8 points. How many edges? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 12 edges, right? So this is still using the viewer draw, but if you like, you can use just a B-mesh viewer. And with a B-mesh viewer, you have a real object. Turn off viewer draw, you have a real object here. And you can use the matrices. This is of course the transform. So there you go. You are creating just a simple box from scratch, which is, I think, really cool. At any time in point you want to randomize it, you can use randomize input. It's one of my favorite nodes to do this randomization. But yeah, I think this is really cool. If I can go back in time and doing my live noding from the very beginning, I think this is one of them, and this should be pretty clear of what's actually happening. There is another tutorial by Zefi about Sverchok, how to create a circle from scratch. Sverchok basics, Blender, Python, Sverchok, the basics. What is Sverchok? Geometry nodes for Blender. This will teach you how to create a circle. This one a little bit more complicated, but it's also interesting. Circle might be complicated, but the recipe to create a circle, once you understand it, okay, this is just a trigonometry, and then you use a sine and cosine with a bunch of numbers. It's kind of nice once you understand it. But let's get back to here. The way Ian Scott explained it is really nice. He always explains, he has a lot of video tutorials from scratch, how to make things in Blender and how to make a game and how to also work with Blend for web. I highly recommend you to do this. If this the Python one is something that I'm studying now, it's very useful if you want to learn Blender and Python and how to create a mesh. And this, if you are familiar with this, then you don't need, maybe you never need to use Sverchok. Or I found that to learn Sverchok helps me a lot to make this part simple. This part becomes simple, and then what's gonna happen is that with a Blender, once you understand this mesh data and etc., and you start to think about the algorithm to like a recipe to create these numbers automatically, or you want to kind of wants to arrange the data in different ways so you can have your own custom cube, then you can at some point use just Python and create your own add-on for that. Yeah, but I like to work with nodes. But sometimes I do switch to code once I make this part, once I understand the logic, and then maybe this part is more efficient as a code. Eventually, I heard that you will get to the complex part, and at that point it's really like beyond what someone can learn with a simple tutorial like this. But here, like, this is like 9 minutes tutorial by Ian, and he explained it really slowly and step by step. Very nice tutorial. I learned a lot from how Ian explains a lot of things, Blender and Python. So I use notes because with notes it's kind of visual. I like it to see it this way. And yeah, so hopefully this is useful for non-technical person to learn about mesh data. If I'm using Houdini, or maybe I should open Houdini. So yeah, why not? Let's open Houdini. Houdini is a procedural nodes program. It's similar to what we are seeing here. You create, you work with components data using nodes. Houdini. Okay, connecting to license server. The things with Houdini, I once spent a lot of money, thousands of dollars to buy a license of Houdini, and at some point it doesn't work anymore on the Mac OS. I'm using High Sierra. Houdini doesn't work on High Sierra anymore, and then I was not so happy. I don't think the license ever works again unless I install a different OS, and then maybe it will work. Maybe I should do that because I have a license for older Houdini. This is Houdini 16 or something, 16.5. So yeah, Houdini is a very powerful node-based system. But I just want to show you in Houdini there's something that I quite like. So this is a box object in Houdini, and this is a kind of like a group nodes. You can dig inside, and you have box, and then you can play around with the size. This is Houdini Apprentice version 16.5. This guy create a box, and you can make divisions, whatever. But I want to also show you that, division minimum 2. This box, if you can go inside the geometry spreadsheet and you can see the points. This is the points data. This is the vector. This has x, y, z, and very similar to this guy. Very similar to this guy as well as a node, right? And of course, can we see also the indices? This is the point number. This is also represent the indices, I believe. So in Houdini also points and polygon matters. Edge doesn't really show up in Houdini much. You can also middle click here and look at the data, I believe. So there you can see the point, center, bounding box. Can we see more? Well, not gonna talk about that, but you can see the points, and you can also see the indices, polygon face to represent the polygon face. You can see this is face data, the first face, polygon face, the second one, and the third. We have 6 polygon in total. Each one have indices. In Sverchok, you can actually deal with edges a little bit more elegant than Houdini, I think. A little bit more visual, a little bit clearer. In Blender, we cannot see a spreadsheet like this, but you can do it in different way. You can use a text viewer, if I'm not wrong, viewer text, and then just plug in the data. And where is it? I haven't used this for a while, but there is a way to see this text somewhere. Oh, there we go. That's how we can see the data. This is how Sverchok keep the. This is the indices, right? It's not in a spreadsheet kind of format. It's more like a Sverchok thing. There you go. That's very clear. All the components data. So they are all the same. So once you understand this, you can easily use Houdini if you want or use other package like Maya. So Blender is the coolest one because it's open source. You can just download it, you study it, you understand all how the data works, and then you can easily blend and switch to bigger, like the Big Brother, expensive one, license, commercial, if you ever gonna need to use it. So anyhow, so that's pretty much a big talk of the basics, how you can create a box from the component levels, really like thinking about points or the vectors that generate the points, and then you think about how to create a polygon face. You don't always work like this, mind you, of course you don't always need to work this way. You can, but anytime you can go deep level and kind of stitch your 3D mesh this way. Sometimes you need to go this deep, but very, very likely you will kind of just like, create a random vector. Boom, you will just generate a bunch of points like that. Generate 200 points, scale it, and then create an object based on these points or things like that, like KD3 closest edges. Based on these points, create a bunch of edges, and you get a bunch of edges. You can do this quite easily thanks to the nodes, of course, but the node itself is hundreds hours of work of other person. Sverchok developers made these nodes, so you can have this very, very easily. So that's why it's I think it's very powerful framework, worth running, totally worth your time to learn this. And yeah, anyhow, that's I guess pretty much it for this. Hopefully this helps anyone who wants to use Sverchok to do like 3D modeling and architecture or design works. Very powerful framework for modeling and a lot of things. Okay, so yeah, that's pretty much it, and hopefully this is useful again. And if you have any questions, suggestion, let me know, and I'll see you next time. Thank you. Bye.